Hi! Have you ever wondered how we can create electronics that bend and stretch yet still work perfectly? Or why some materials can conduct electricity while others don't? Well, it is all thanks to Bloch theorem. So what is a Bloch theorem? Bloch theorem is a quantum behavior of electrons in a periodic potential which occurs in a crystalline solid, the materials where atoms are arranged in a repeating ordered structure called a crystal lattice. In the lattice, Bloch theorem tells us that the electron's wave function can be written as where the right hand is a plane wave component and a function that sheds the periodicity of the crystal. This form shows that the electron retains wave-like behavior while being influenced by the periodic structure. As a result, electrons in a crystal are not localized to individual atoms, but instead they propagate across the entire material, which also called as delocalized electron. Because of this delocalization and due to interference effects caused by the periodic potential, the electron energy levels are no longer discrete, as in isolated atoms. Instead, they merge into continuous range called energy bands, separated by regions called band gaps. This gives rise to three types of materials, which are the conductors, semiconductors, and insulators, depending on the size and position of these bands. In semiconductors, the energy gap between the valence and conduction band is small, so electron can be excited into the conduction band when energy like photon is absorbed. This concept is applied directly in flexible solar panels. These panels are made using materials such as organic semiconductors or thin films that, while not perfectly crystalline, it still possess enough periodicity or local structure to support Bloch-type wave functions and form energy bands. When sunlight hits the panel, photons provide energy to excite electrons from the valence band into the conduction band. Because the electrons are delocalized, they are free to move through the material and are collected as electric current. This process, like absorption, electron excitation across the band gap, and free electron movement, is only possible because of the energy band structure formed due to Bloch theorem and electrons' delocalization. What makes this application especially powerful is that flexible solar panels can be lightweight, bendable, and easily installed on curved surfaces, clothing, vehicles, or in remote environments. Their designs use less materials, lowers energy costs, and enables clean, off-grid electricity. This directly supports Sustainable Development Goal 9 (SDG 9) by encouraging innovation in green technology, sustainable industrial processes, and resilient infrastructure that is adaptable, accessible, and environmentally responsible. Thus, Bloch theorem is not just a mathematical statement, but it is a foundational concept that makes modern sustainable technology possible. That's all. Thank you.